All right, going to work out the 8.5 problems here. So some pretty straightforward ones. Find the work done, integrating from 0 to 3 for this one, whatever. So this is work is the integral 0 to 3 x sine pi x over 4 with respect to x. Now, fun times here. Got to remember some of your old calculus. So let's see what you got. U equals x, du equals dx, dv equals sine of pi x over 4, v equals -4 over pi cosine pi x over 4. Well, let's check that. So derivative of cosine is negative, negatives cancel out, sine's there, pi over 4 cancels, we're good. So, what do we got here? Equals, right here, -4 over pi x cosine of pi x over 4 minus the integral of, and I will put positive 4 pi out front, cosine pi x over 4 dx equals -4 over pi x cosine of pi x over 4 plus, looks like it goes 16 over pi squared sine of pi x over 4, 0 to 3, which if you blast out, you get 3.847 joules. Highly recommend doing that one so that you get some practice on integration by parts. Number 2, looks like U substitution to me. We're going from 0 to 10. U equals sine of x. Du equals cosine of x dx. Du over cosine of x equals dx. U of 0 equals 0, because, pardon me here, sine of 0 is 0. U of 10 equals just sine of 10. So work equals the integral from 0 to sine of 10 e to the u cosine of x interesting. Replace the dx with du over cosine of x. Yes, I know I missed the 10. Plus the integral from 0 to sine of 10 of 2. Yeah, no, this one I don't need substitution. So leave as 10 and I'll leave it as dx. Crazy, huh? Equals integral of e to the u is e to the u, sine of 10, 0, plus 2x 0 to 10, which is e to the sine of 10 minus 1 plus 20. Going for decimal, we get 19.580 joules. Of course, you can combine these two here and get 19, but I'm being lazy. Bag of sand, originally weighing 144 pounds, is lifted at a constant rate. Sand leaks out. It's half gone by the time it gets up to 18 feet. Well, at least there's some sand left. So we need to do this nonsense. The weight of the sand at the bottom is 144 pounds. All right, so we don't have to worry about lifting equipment or the bag. And the weight after 18 feet is 72 pounds. So the slope is, we'll go with 72 minus 144 over 18 minus 0. And that gets us -4. And that would be pounds per foot. We don't really worry about the units here, but in case you're wondering, drops 4 pounds every foot it goes up. Oh yeah, 4 times 18, 72, that makes sense. And then the force. So the force is -4x plus 144. That's just point slope with this. Y minus 144 equals -4 times x minus 0. 0 is gone, add 144 to both sides. So the work is the integral from 0 to 18, -4x plus 144 dx equals -2x squared plus 144x, 0 to 18, which after we blast it all out is 1,944 foot-pounds. There's no joules here. Just like Newton meters, we call it foot-pounds. Yeah, that's it. A spring has a natural length of 10 inches. 800-pound force stretch the spring 14 inches. Whatever. F of x equals AX, unless I'm very mistaken. And 800 equals K times 14. K equals phooey, I did this wrong in my notes. Now I've got to do math. That's horrible. 800 over 14, also known as 400 over 7. Sure, whatever. That's pounds per inch or something like that. If we're going to be, let's do it right. Not too bad. All right, so find the force constant, how much work is done from 10 inches to 2 inches. Okay, so integral from 10 to 12, I say 2, weird, of 400 over 7x dx is 200 over 7x squared, 10 to 12. Actually, I have to get my calculator out for this one. So I get 8,800 over 7. We usually write it as foot-pounds, yeah. We're going for that decimal, we get 1,257.143 foot-pounds. Either one. Okay, how far beyond its natural length? Well, a 1,600-pound force, so that's actually right over here. So 1,600 equals 400 over 7. Sorry, I had to think about this for a second. So X equals inverse and all that fun stuff. 28 inches. At this moment, we'll stop for a second and make sure we're all good on that. Spring has a natural length of 10 inches. This is probably wrong up here. Need to transport specials to the spring to 4 inches. That's why all my math showed it with 4. Well, I should learn to read the question. So that's my mistake. So this is actually 4, 200, which is what I had earlier. 0, 2, 200. 100, 0, 2. That gives us 400. By the way, inch pounds. Lovely. And this would be 1600 equals 200x. So this would actually be 8 inches. All right, it happens. No big deal. So bathroom scales, compressed bathroom scales work off of these springs. So compressed 1/16 of an inch, 150-pound person stands on it. Assume it behaves like a spring. How much does someone compressed scale 1/8 of an inch weigh? We just set up our proportion, but we'll do it all the long way. So 150 pounds, K times 1/16. K equals 2,400 pounds per inch. So our F of X is 2,400 times X. So how much force is on that when we get eighth of an inch? Their weight is 300 pounds. Oof, that's big. How much work is done? That's the integral from 0 to 1/8 of 2,400 x dx, which is 1,200 x squared, 0 to 1/8, which is 18.75. I don't go 3 decimal places because I don't have a third decimal place. Inch pounds. Mountain climber is about to haul up a 50-meter length of rope. How much work will it take if the rope weighs 0.624 Newton meters? Well, the weight originally is this 0.624 times 50 meters, which is 31.2 newtons. And when it gets to the top up to 50 meters, it'll weigh 0. So I've done this many times. I'm not going to write it all out again. You do your change of y for change in x, and then set it equal and yada yada. So you should get negative 0.624x. Oh, that looks familiar. Plus 31.2. Oh, that looks familiar. Times 0 weighs 31.2. At time 50, it's going to weigh 0. Right. So how much work? Well, that's the integral from 0 to 50. Negative 0.624x plus 31.2 dx. Negative 0.624 over 2 x squared plus 31.2x. 0 to 50. Equals 780 joules. Or Newton meters, if the case may be. That's it. Have fun.